Okay, so in the second part of looking at multi-step calculations with sig figs, we're going to do another problem. Let's say we have 14.037. Let's go ahead and add 2.5 times 103.6 to it. So 14.037 plus 2.5 times 1.036. Now we'd follow order of operations. We'd do this one first, and if you do this, you get an answer of 259. But you should pay attention to the fact that you multiplied. So every time you multiply, you pay attention to sig figs. This has 2, this number has 4, so this answer should technically have 2. We don't get rid of this 9 yet, though. We don't round or anything. We just pay attention to the fact that this answer technically only has two sig figs. In other words, we know the hundreds and the tens place. Let's move on to this. Now we're going to go ahead and take that 259, underlining it, paying attention to the fact that it only has 2 sig figs, and we'll add 14.037 to it. Now when you do this, you get an answer of 730. And this would obviously be 3, carry the 1, 7, and a 2. So you get an answer of 273.037. And now we go to add. Well, this number was given to us for the 14.037. We know all the way down, not the tenths, the hundredths, the thousandths place, we know all the way down to. But here, again, we only know to the tenths place. That's what we underlined. So your question is, which one is the least precise? Because when you add, you have to pay attention to precision. Here again, we know the hundreds, the tens. We do not know the ones. This 9 we carried over, but we really didn't know it. So we draw our precision line there, telling us that we only know the hundreds and the tens place, and that's it. So when we put this number in scientific notation, first we should ask if this number is 5 or greater, in which case we would round up. It is not, so we just truncate it. Our answer is essentially 270. We know the 2 is in the hundreds place, the 7 is in the tens place. We don't know anything over here, so we just put a 0 in place of it. Our answer in scientific notation would be 2.7 E2.